On April 11, 1970, Apollo 13 lifted off from Kennedy Space Center on what was expected to be another routine mission to the moon. 3 astronauts were on board, heading toward humanity's third planned lunar landing. Commander Jim Lovell, Jack Swigert, and Fred Hayes had spent years preparing for this mission. During the first 2 days, everything appeared to be going exactly according to plan. The spacecraft traveled farther from Earth with every passing hour, while the crew completed routine tasks and communicated normally with mission control. Nearly 320,000 kilometers from Earth, nothing seemed out of the ordinary. Then, during a routine equipment check, everything changed. Within seconds, Apollo 13 became one of the greatest survival stories in the history of space exploration. Nearly 56 hours into the mission, the crew was asked to perform what seemed like another routine procedure. Jack Swigert flipped a switch to stir one of the spacecraft's oxygen tanks, a task that had been completed safely on previous Apollo missions. Only seconds later, a loud explosion shook the spacecraft. At first, the astronauts struggled to understand what had happened. Warning lights suddenly illuminated the control panels as electrical systems began failing one after another. Oxygen was rapidly escaping into space, causing fuel cells to lose power and placing the entire mission in immediate danger. Inside Mission Control, engineers watched the incoming telemetry with growing concern as critical readings continued to drop. The mission that had been planned as a journey to the moon had suddenly become a race against time. Every decision made over the next few hours would determine whether the 3 astronauts would ever return to Earth alive. As the crew checked their instruments, the seriousness of the situation became impossible to ignore. Telemetry arriving in Houston showed multiple system failures occurring at the same time, while oxygen levels continued falling. Then Commander Jim Lovell contacted Mission Control with a calm but unforgettable message. "Houston, we've had a problem." Engineers quickly confirmed that one of the oxygen tanks had exploded, severely damaging the spacecraft's service module. Without enough oxygen, the fuel cells could no longer produce the electrical power needed to keep the spacecraft operating normally. The mission could no longer continue toward the moon. Instead, every available engineer and flight controller focused on a single objective: finding a way to keep the crew alive and bring all 3 astronauts safely back to Earth. From that moment forward, every minute became critical. Mission Control understood that reaching the moon was no longer possible. The mission had instantly changed from exploration to survival. Engineers decided to use the lunar module as a lifeboat, even though it had never been designed to support 3 astronauts for such a long journey. Every watt of electricity and every drop of water suddenly became critical. To conserve power, nearly every non-essential system was shut down, leaving the crew in freezing temperatures. Inside the spacecraft, the astronauts carefully followed every instruction sent from Earth, knowing that even a small mistake could put the entire mission at risk. The smallest error could determine whether the crew survived. Every decision from this point forward had to be perfect. As the journey home continued, a new danger slowly began to threaten the crew. Carbon dioxide inside the lunar module was steadily increasing, creating a serious risk for the astronauts. Engineers searched for a solution using only the materials already available inside the spacecraft. Their challenge was to connect equipment that had never been designed to work together. Using plastic bags, cardboard, hoses, and duct tape, Mission Control created an improvised carbon dioxide filter. The crew carefully assembled the device by following detailed instructions sent from Earth. When the system finally began working, carbon dioxide levels started falling. For the first time since the explosion, the crew had a renewed chance of making it home alive. Although the moon landing had been canceled, Apollo 13 still had to fly around the moon before beginning its journey back to Earth. The moon's gravity became the crew's only chance of returning home safely. Mission Control calculated a precise engine burn that would place the spacecraft onto a safe return trajectory. Even a small error could send Apollo 13 thousands of kilometers off course. With limited electrical power available, the astronauts performed the engine burn manually, carefully following instructions from Mission Control. There would be no second attempt. Everything now depended on whether those calculations had been correct. The crew could only wait and hope they were finally heading home. After traveling hundreds of thousands of kilometers, Apollo 13 was finally approaching Earth. Before re-entry, the crew carefully powered up the command module using procedures created during the emergency. As the capsule entered Earth's atmosphere, temperatures outside climbed to thousands of degrees, surrounding the spacecraft in a layer of superheated plasma. Mission Control suddenly lost all communication with the crew. The radio blackout lasted longer than expected, and every passing second made the silence even more unbearable. Engineers could do nothing except wait and watch the countdown. Then, after several tense moments, the astronauts' voices finally returned. Against all odds, Apollo 13 had survived re-entry. Moments after communication was restored, Apollo 13 safely descended beneath its parachutes toward the Pacific Ocean. The spacecraft splashed down exactly where recovery teams had been waiting. U.S. Navy rescue teams quickly secured the capsule before helping the astronauts leave the spacecraft. Despite everything they had endured, all three astronauts were safely recovered. What had begun as a mission to land on the moon had become an extraordinary demonstration of teamwork, engineering, and determination. Around the world, millions celebrated one of the greatest rescues in the history of space exploration. The mission had failed to reach the moon, but it had succeeded in bringing everyone home alive. After the crew returned safely, NASA immediately launched a detailed investigation into everything that had happened. Engineers carefully examined every system, every decision, and every piece of damaged equipment. Investigators eventually traced the accident back to a chain of technical failures involving one of the spacecraft's oxygen tanks. The findings led to important design improvements for future Apollo missions. Only a few months later, NASA resumed lunar missions with stronger safety procedures and improved spacecraft systems. The lessons learned from Apollo 13 helped make future missions safer for every crew that followed. What could have become one of NASA's greatest tragedies instead became one of its greatest achievements. More than 50 years later, Apollo 13 continues to inspire engineers, astronauts, and millions of people around the world. The mission proved that preparation, teamwork, and calm decision-making can overcome even the most unexpected challenges. Many of the lessons learned from Apollo 13 continue to influence space missions even today. Every new mission carries knowledge earned through the successes and failures of the past. Apollo 13 reminds us that exploration has never been free from risk, but every challenge has helped humanity move one step farther. What people remember most is not the failure, but the determination that brought 3 astronauts safely home. The story of Apollo 13 reminds us that courage, teamwork, and human ingenuity can overcome challenges once thought impossible.